In this video, we're going to use the completing the square process to switch to vertex form by hand. So a couple background pieces. We're going to do the second example. The first and last examples are in other videos. So this video is just this little one. We know that standard form or general form is y equals ax squared plus bx plus c. The completing the square process can get pretty complicated pretty quickly, and we have a calculator. So we are going to limit ourselves to doing this by hand algebra when a is 1. When a is 1, our strategy says that we are to add and subtract b over 2 squared. So the first thing I do is I locate in my given equation that this negative 6 is the b value. So now I'm going to take this formula, which is to take negative 6 over 2 and square it. I am going to show my math by hand because it ends up being useful later in the process. So negative 6 divided by 2 is negative 3, and that gets squared. So 2 negatives make a positive, so negative 3 squared is 9. So now I'm going to rewrite, and I know that vertex form, so this vertex form is the form where we have y equals a x minus h quantity squared plus k. So in that vertex form, I have this x minus h factor, and so I know that I want to be able to factor the formula. So what I'm going to do is I'm going to write x squared minus 6x, and I'm going to leave a space, and I put the plus 7, and I have another space. So this is where I very strategically am adding 9 and then subtracting 9. And as we've talked about before, adding and subtracting, the net value of what we've done is 0, so it does not change the formula, but it does change the look of it. And I wanted to be very strategic because this 9 that I got is the third piece to make this first trinomial factor perfectly for me. So y equals, I put my 2 sets of parentheses because I'm going to factor that, and then I can do the math that is beyond that trinomial. So 7 minus 9 would be minus 2 or negative 2. Now for the factoring, factors of x squared are x and x, and we want factors of 9 that add up to negative 6. Well, the really cool thing about this is that if I go back to where I used the process, this number inside those parentheses is the factor to use. And so I will use negative 3 and negative 3. I can see that they multiply to give me 9. I can see that if I add them, I have negative 6. So this fits my check for factoring. I then rewrite, since my factors match, which will always be the case in this process, I have x minus 3 quantity squared minus 2. This is in vertex form. So from this, I can tell that the vertex, which is either a minimum or maximum point, and we'll discuss that in a moment, is the ordered pair 3, negative 2. And that is by matching up to the original formula here. Sorry, I have a 7 there instead of a k. In that original formula, the h has that negative, so that's always a sign change. So you see that sign change from negative 3 to positive 3. The k value is directly from the formula, so the negative 2. Now, the a is the one that controls whether you have a concave up or down graph, and so our a, being an unwritten 1, means that we have a concave up graph because it is positive. So if we find the ordered pair over 3, down 2, that is the minimum point, and we have a parabola that is going to open upward, be concave up with that minimum point, which is why we would find that vertex. It gives us a really great picture of where the parabola is without doing the graphing itself. So I'm always going to give you this process. So in this process works when the a is 1, and then you take the b divided by 2 and square it, and you just add and subtract that, and you do that very strategically, putting that addition to make a trinomial that will factor, putting the subtraction to keep the equation balanced.